A series circuit consists of a resistance 600 ohms and an inductance of 5 Henry, an AC voltage of 15 volt root mean square, and frequency 50 Hz is applied across the series circuit. Calculate the current flowing through the circuit, the voltage across the inductor, the phase angle between I and the applied voltage, the average power supply, the PD across the resistance. The situation of this question have this diagram. You have that's the resistor connected in series with an inductor. The value of the resistor is 600 ohms. The inductor is 5 Henry. The connection is made to an AC source. The voltage is 50 volts, root mean square value, and the frequency is 50 Hz. The first question asks the current flowing through the circuit. The current flowing will be given as the root mean square current is equal to the root mean square voltage all over the impedance of the circuit, because there's resistor and inductor. The impedance of the circuit is the square root of resistance square plus inductive reactance square. So we need to find the inductive reactance, which is given by the expression 2 pi frequency and inductance. Pi is 3.142. The frequency is 50. The inductance is given as 5. Using a calculator, that will give us 1571 ohms. With that, we can now find the impedance of the circuit. The square root of, using this expression, the resistance is 600 ohms square. Inductive reactance has been calculated as 1571 square. Using a calculator, that value will be the impedance of the circuit will be 1681 ohms. 1681 ohms. From this, we can get the current given by this expression. The root mean square voltage all over impedance. Substitute the value. The root mean square voltage is given as 50 here. The impedance calculated as 1681. Using a calculator, the current flowing, the root mean square current, is approximately 8.88 times 10 raised to the power minus 3 ampere. This can be reduced to 8.88 milliampere. And next question, we're asked to find the voltage across the inductor, that is VL. The expression is given as the current, the root mean square current, multiplied with the inductive reactance. The calculated current is 8.88 times 10 to the power minus 3. Inductive reactance from the question there is given as 1571. Using a calculator, that will give us 14.95 volts. 14.95 volts. The next question, we are asked to find the average power, we have to find the phase angle between the current and the applied voltage. In this circuit, having a resistor and inductor, The first angle tan phi is given by the expression inductive reactance all over the resistance. The inductive reactance from our calculation here is 1571 and the resistance is 600. The resistance is 600. We can make phi the subject of formula. That would be the tan inverse of 1571 all over 600. That will give us the phase angle, approximately 69.1 degree. We also have to find the average power supply. The average power supply. The average power supply, as that should be given by the expression, the current square and the resistance. This current will be the root mean square current, the effective current. And the current, we calculate the current to be 8.88 times 10 raised to the power minus 3. The resistance of the circuit is 600. If we multiply that using a calculator, we'll have the average power to be 4.73 times 10 raised to the power minus 2 watts. The last question, we have to find the PD across the resistance. The PD across the resistance. The PD across the resistance given by the expression VR is equals to the current times the resistance. This is the root mean square current. The root mean square current multiplied with the resistance. The root mean square current is given as 4.73. Now, this is the root mean square current. The root mean square current from the calculation we have here 8.88. 8.88 times 10 raised to the power minus 3, and the resistance is 600. Using a calculator, that will give us 5.33 ohms. That is the PD across the resistance.